G'day and welcome to the final question of the SAT, which was the absolute doozy. So what we had to do is we had to create equations that describe the curve of at least two of these arches on this bridge. I believe it's in China. Now, the thing that a lot of people did was they measured from here. They measured from above the water, but if you look at the water line, well, that's on 0. So if you can match your curves to what's going on here, that makes your life a little bit easier. Every single one of these horizontal lines or vertical lines is 20 units. So by that logic, if I place a mark here at the bottom of this curve here, I can see that it's going from 80 all the way to 180. Which means the top of my curve will sit halfway between here at about 130. And because this is also 20 meters each time, I know that I therefore have a turning point at about 40. So that means I'm looking for an equation that has intercepts at 80 and 180, and then also 130 and 40 as the turning point of the graph. And that's where a lot of people got mixed up, is what they did was they tried to just simply do through intercepts when realizing, hey, if I use the turning point, I can make my life a lot easier. So the idea would be that you guys would then figure this out. So for example, if I describe it in turning point form, I have y equals a x minus h squared plus k, recognizing that this is a negative parabola. So there's going to be a negative out the front here. So my turning point is at 130 and 40. So 130 and 40 x minus 130 squared plus 40. And then you would need to expand this or do some manipulation with this to get basically an expanded version. However, there is also another way of doing it, another way of trying it, because we also have the intercepts. We have the intercept form. We could find the exact value of A by creating simultaneous equations and doing it this way. So in this case here, I have, because I know that the intercepts are at 80 and 180, I also have the equation y equals x minus 80, x minus 180, and then I have a dilation factor at the front, which makes the whole thing negative. So y is equal to negative a x minus 80, x minus 180. And look, I can put those back to back and then see where I go from here. So and then from there I should be able to solve for A. So if I, for example, were to take, I can put these back to back. Actually, they'll just cancel each other out. But what I can do is take the point that I know here, put it into here, and see what values I get. Or I can take this value here and put it up into here and see what I get. So there are two ways of laying out this equation, but both would require you to eventually have to find this A value. All right, so let's take the point here. When x is 80, y is 0. I'm going to put it into here, because if I put x is 80, y is 0 to here, the whole thing equals 0, and I don't get A anyway. But I still need to find out what that A value is. So 0 equals negative a so when x equals 80, y equals 0. So when x equals 80 minus 130 squared plus 40. 80 minus 130 is going to be negative 50. So it's going to be negative a negative 50 squared plus 40. Negative 40 equals negative a 50 squared. 50 squared, what's 50 squared? 50 squared is 2250. Yeah, 2,500. So in this case here, it's going to be positive 2,500. Because they're both negatives, I can just get rid of the negatives and therefore get my value of a equals 40 over 2,500. Now, if I were to take the 130 and to put it into here, I would also end up with the same value here. So I know that the equation that describes this line here is going to be y equals negative 40 over 2,500 x minus 130 squared plus 40. All right, and you would repeat this logic for the other loops in the thing. So if I clean this off, ta-da! You would also want to try doing the same logic with some of the other values that we have here. So in this case here, we will still use this one here at 180. I would look at here for 300 because that's what it says there. And then I would look halfway between 180 and 300 at about 240. And I would use this point here at the top there. And because that's 20, 40, 60, I would say this is about 50. And then going over the other one here, I would say this one here is about 450. So it's 300 to 450. So this one here would be at about 375. And it would be probably, I would say, 82. And then for the last one here, 450, I would say that that is, yep, about 550. Top is at about 500, which is at about 40 meters as well. You would use those numbers and the same process that I did above, and that will be the best way to solve this problem.